Our project was the inverted pendulum. The system consisted of a 3D printed body and wheels with O-ring washer tires, a 12-volt DC motor from a home printer, a solid steel axle from the same printer, gears from an RC helicopter, an Arduino, an Adafruit absolute orientation sensor, and an Adafruit DRV8871 DC motor driver.
The sensor that we are using is a 9 degree of freedom absolute orientation sensor. The sensor board uses a Bosch BNO-055 MEMS sensor that includes a 3-axis accelerometer, a 3-axis gyroscope, a 3-axis magnetometer, and a thermometer.
The board also includes an ARM Cortex-M0 to process and filter the accelerometer/gyro data to output the absolute Euler angles and angular velocity. These values are then read into the Arduino using the function analog read. We are able to read our input at 100 Hz.
Here you can see the transfer function for our pendulum. We use the small angle theorem to assume that sine theta equals theta. You can see from our block diagram that we obtained a corrected angle from the sensor and angular velocity from the sensor gyroscope.
We also attempted to determine the exact transfer function for the motor. However, due to the difficulty of finding a rotary encoder, we were unable to derive the motor constants, so we made general assumptions and iterated on our Kp, Ki, and Kd terms until we found a stable system. Since the sensor we used was digital, we did not have a sensor transfer function since it already gave us values in degrees and radians per second.
When completing the initial tests, we discovered that we could never get our set point angle to be correct due to the shifting of weight when the robot would crash. This led us to start using the excess axle rod as a way to pseudo-adjust our set point by repositioning our center of gravity.
We were able to get the pendulum to stay upright in this configuration for 1 minute and 15 seconds. This rod was 3.3 ounces, which will be treated as our lowest weight held for stability. We were also able to get the pendulum to stay upright for 18 seconds while holding 6 pounds 6 ounces, which was our largest weight held for stability. This results in a maximum disturbance rejection of 6.42 pounds and a disturbance rejection ratio of 31.12.
We're rolling it whenever you're ready.
Took her on his ship, took her out to Vegas, no return trip. Robots rise up, robots rise up, robots rise up, robots rise up. I'm a teenage wolfman, Frankenstein's my friend. Mommy's over there, just about to mend. Robots rise up, 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 robots rise up. Robots rise up, yeah! Once they get together, they have things well in hand. Robots rise up, robots rise up, robots rise up, robots rise up. Land a time forgot, terror from the sea. Journey to the center, the earth is on its knees. Robots rise up, robots rise up, robots rise up, Robots rise up. Robots rise up. Robots rise up. Robots rise up. Robots